Hello everyone, welcome back to my channel once again. I hope all of you are doing so great in your life. So, today we are going to discuss about Newton's third law of motion and the conservation of momentum. So, all of you can take out your notebook so that you can note down the important points. And without any further delay, let's start today's topic. Hello everyone, welcome back to my channel once again. I hope all of you are doing so great in your life. So today we are going to discuss about Newton's third law of motion and the conservation of momentum. Okay, so without any further delay, let's start today's topic. So Newton's third law of motion. Have you ever punched in a punching bag like the boxers do? So what happens when you are punching? The punching bag is moving away from you, right? But does that hit your hit your like hands also? Is it causing pain in your hands also? Yeah, it is, right? So what is happening over here? See, for every action, there is an equal and opposite reaction. And this is the Newton's third law of motion. Okay, so if you are fighting with your friends or somebody, so what happens? Your intention is to hurt that person, right? Like you are fighting, you are slapping that person or you're punching that person. Your intention is to hurt that person. But for every action, there is an equal and opposite reaction. So when you are punching or slapping, so is that you are hurting that person only? No, you are hurting yourself also. Okay, so it's first of all, fighting is a not a good thing, so you should always avoid that thing. But even if you are fighting, just remember that you are just not hurting the other person, you are hurting yourself also and equally. Okay, so because Newton third law of motion says that for every action there is an equal and opposite reaction. So suppose you are punching someone with a 5 Newton of force, so your hand is also having that much amount of force only. Your hand is also experiencing that much amount of force. So you are having the pain in your hand also. Alright. So here you can see in this example, this boy is trying to jump from this boat. So when we are jumping from the boat is in the water and he is jumping from the boat towards the land. So this boy is exerting a force on the boat. That's why the boat is going to move in the opposite direction. Okay, and that's how we are coming out of the boat. One more example is that, so whenever we are using a gun, so of course we are a common public, so we don't use a gun, but the policemen and the army men, they use a gun, right? So what happens whenever they are firing from a gun? So there is a force, is recoil force of the gun is also applied on the shoulder, and this is the reason that shoulder is moving in the backward direction. So as this bullet is having like so much of momentum, okay, so this is moving in the forward direction. So this is applying a force on the opposite direction. So that's why there is a recoil force is occurring. Okay, this is the Newton's third law of motion. So for every action, there is equal and opposite reaction. So always just, this is not for any objects. This law is basically applicable on our life also. So for just deciding, taking every decisions in your life also, there is obviously there is a equal reaction is going to happen. Okay, maybe it's not opposite, but it will be like reaction will be happening. So this is a very good law. All right, it's it's applicable in our life also for every action. So whenever you are just arguing with someone else, there will be, of course, there will be opposite reaction from that person also. Okay, so that's a different thing. That's about any some life suggestion. But here, this is for this law is applicable like for the any objects. All right. I hope this is clear to you. Moving on to the next. Here you can see like there are some balls are hanging, and when this person is like using this ball, you know, with some force, so this ball is basically helping to move the other ball also. You know, this ball is helping to move all the other balls also. So how all the other balls are moving? What do you think about this? This person is only moving two balls, but how the all the other balls are moving? And that also this in this direction, this right side ball is also moving to the same height only. How this is happening? This is happening due to the conservation of momentum. Okay. Now, what is this conservation of momentum? So, first of all, before understanding the conservation of momentum, we need to understand what is a system. Okay, what is a system? So, system is nothing but it is the objects which we are considering for any experiment. Okay, like for this, the system is this portion only, the balls. Okay, not the other portion. Even air is not also not the part of the system. So system will be something which will be which won't be having any impact from the external environment. Okay, so everything outside the system is called the environment. So in this scenario, this this particular setup is called as the system. Okay, so for example, a car is moving with a constant velocity can be considered as a system. All the forces within the car are internal forces, and all the forces acting on the car from the environment are called as the external forces. So total momentum of the isolated system is always conserved. All right. So that momentum is always conserved. So what is basically the law of conservation of momentum? When two objects are acting on each other, their total momentum remains constant provided no external force are acting on it. So there should be no external force, no even no drag force, no force by air also. Okay. So then this law is applicable and it says that initial momentum is always equals to the final momentum. Okay. Let's do watch this video to understand this concept in a better way.
Conservation of momentum tells us that the total momentum in any closed system will remain the same all the time. And since momentum is equal to mass times velocity, even if you have multiple objects going at different speeds that might collide, for example, the total momentum of the system before and after the collision will remain constant. So for example, these two balls, which in this case happen to be of equal mass, whether one of them is moving and causes the other to move, or they're both moving and collide and move off in different directions, the total speed and the total mass of the entire system always remains the same. So for example, if this had a velocity of 0 and that had a velocity of 1, the first one might impart some of its momentum onto the second, but the total between the two remains the same. And that remains the same whether one remains still and the other comes to collide with it, or whether they're colliding with each other. It even works, in this case I put Velcro, it even works if these two stick together, the total momentum remains the same. So for example, if I can get these two to stick together while one is stationary and the other is moving towards it, once they stick together, the total momentum remains the same, so the combined objects will have half the velocity of the one initially that was moving. Conservation of momentum makes it actually quite interesting and challenging to move around the ISS if you don't have something to reach onto a handhold. Because if you get trapped out in the middle, there's no wiggling you can do, no swimming you can do that will get you over to a handhold so that you can pull yourself to move through the station. Because no matter what I do here, if I just stay floating in the middle, I'm just going to remain here in the middle since the total momentum of the system has to remain constant.
All right, so this video was shooted in the International Space Station. So you can see that everything is like floating. So there is of course no external forces applied. And when they're applying the force on the ball, so ball is colliding with another ball. So when the ball is colliding with another ball, the total momentum of that particular system is always remaining the same. Okay, so first ball is having some speed, so first ball is having some velocity and mass. When the first ball is hitting the second ball, that momentum of the first ball is getting transferred into the second ball, and that's why the second ball also starts to move with the same velocity. Okay, so here you can see from this we can derive this equation m1 u1 plus m2 u2. Okay, u1 is the initial velocity of like ball 1, and u2 is the initial velocity of ball 2. Okay, m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. Okay, so this is the momentum. Now here you can see the momentum is changing, right? Here we can see the derivation of this equation only. Okay, this is the basically formula. Now I'm just going to tell you how we have derived this formula. So basically momentum is changing, momentum is changing from like ball 1 to ball 2. Correct? So change in momentum in a like of A will be m1 v1 minus u1, and for the b will be like m2 v2 minus u2. Correct? Like this is for the ball 1 and this is for the ball 2. So according to the third law of motion, this is the third law, force uh, applied will be like there. If we are applying, and if there is a action, there will be always a equal and opposite reaction. So here that's why we are using a negative sign. Okay, so now F is equals to ma. We know that from the second law of motion. So just put the value of a over here. Okay, v2 minus u2 upon t. For this also v1 minus u1 upon t. That will be the acceleration. Okay, now just as this law is saying this will be equal, so we are doing this, and when we after the calculation finally we will be getting this equation. Okay, so this is the law of conservation of momentum. So I hope this is clear to you. So today we have discussed about Newton's third law of motion and the law of conservation of momentum. If you like this video, please do hit the like button and subscribe to my channel. Share this with your friends also, so that they also get some help in the science topic. All right. So take care. Have a nice day, all of you. Bye bye. See you again in the next video.